Worksheet 5A column buckling, and this problem have two parts, A and B. So let's start with A, the rectangular cross section. So we have that is 3.2 inches by 8 inches. So if we draw the cross section here, then we have 8 and get 3.2 inches. So if we call the axis here is y and the axis here is x, then and it from A36 steel column. So if we get from appendix B, we have sigma y equal to 36 ksi, pins at both ends. So as you can see, regardless of which direction it pins at both ends, that we can determine the K, which is the effective length factor. And the question is, what is the factor of safety with respect to buckling, with respect to yielding, and is a long or short column? So that long or short column, I suggest you to go back to review the example in the lesson note part 3 and also the demonstration in the video part 4. So as you can see, let's talk about the first is the buckling. We need to consider both buckling and yielding or crossing. So let's talk about buckling. So for buckling, we have the critical load. P critical is equal to pi square EI over KL square. And what is E for the steel? E is the material properties. We already know that is for steel A36. E the modulus of elasticity 29 10 power 6 psi or 29,000 ksi, kips per square inch. And what is I? Which I we are going to find out? So we have two I, as you can see from the cross section here. We have the area moment of inertia. If you go back to the back cover of our book for the rectangle, ix, iy, as you can see, bh cube over 12 or b cube h over 12 depends on the parallel perpendicular of the size. And remember, when we have in the area moment of inertia, I say that the I determined by parallel power 1, perpendicular power 3 divided by 12. So let's apply it here. If I divide x is perpendicular to 8 inches as shown in there, so you can have that ix equal to 3.2, which is the parallel, times the perpendicular cube divided by 12. And with that one, what do we get in here? What do we get for that components? 3.2 times h cube divided by 12. So we will have that is 136.5, and the unit is inch power 4. And now we have Iy equal to, I define Iy perpendicular to the width, which is 3.2 inches. So it will be that, it will be the cube. So it will have 8 times 3.2 inches divided by 12. And which number we have it 21.8 inches 4. And with that too, we want to know which Ix or Iy I'm going to use in determine the area moment of inertia in the critical load that have Euler equation here. So from that, I want to stop here and demonstrate which one I'm going to use, and that demonstration is very important for you to apply this concept in part A and also part B when we have many factors that affect in determine the critical load. For a column with a compressive axial load, we have to consider the buckling effect, and that determine with the critical load of P Euler that make the member to buckle, and that equal to pi square EI over KL square. And as you can see in that critical load for buckling, it depends on E, which is the Young modulus, the modulus of elasticity. So that depends on the materials, is one of the material properties. And then I is area moment of inertia. So it depends on the cross section of the member. And then K, effective length factor, it depends on the support condition or the end condition of the member, and L is the actual length of the member. So in the problem that you have to check with the buckling, one thing that we have to do is how to determine the area moment of inertia. So for a cross section just like rectangles, and we already learned in area moment of inertia, the area moment of inertia in y and in x-axis are not the same. So which one we are going to pick, and that I'm going to present now. So you see a member, I want to determine the buckling. And for the cross section, as you can see here, I got the thickness of this member EB, and the width of that member, I call it H. So from that, I have a cross section from that members is in here that you see there. It B and H. So that is the width and the height of the cross section I just showed you. And let me call X is the axis perpendicular to H, which is the length of the cross section, and B is the the Y axis perpendicular to B. So in that, let's see how the member is buckled. So let's show it in here. So you see the member we're just talking about, and now let me put that in the H and B for the cross section. And now if I compress that member, and you can see the member deflect, laterally deflect about y-axis, not x-axis. What does that mean? As you know, in the area of moment of inertia, for the B smaller than H, then the Ix, it will be greater than Iy. And with that, the column, if we in compression, and that way the member tend to buckle about y-axis, not x-axis, in the case that I show it in here in the weakest direction. And with that, for the I in here, in that equation, you need to determine the Iy if we define the cross section in this way. So that is the one scenario. You will see a scenario that the x and y component have the support condition are not the same. So in that case, you have to find out the critical load. Here, the critical load for two scenarios. What is the critical load in x direction? What is the critical load in y direction? And you see whether the members, it will be buckle or lateral deflection about x or y axis. So sometimes you have to separate to calculate two critical in about x axis and about y axis before we determine which is the most critical load that create the member buckle. So with that two scenarios, the problem worksheet 5a, you will determine the I in y direction because the support condition, the end condition for x or y are the same. But for the part B in worksheet 5a, the support condition or the end condition in y-axis and x-axis are not the same, then you have to determine the critical load for both and then compare those two. And let's get to that detail because that is very critical concept to understand. So I suggest you to look carefully, practice carefully for problem 5a before you practice another problem which have the similar concept later on. So from that demonstration, we have to choose the IY for the I in the critical load. And when for the part A in worksheet 5A, both direction have a pin at both ends, which have the same end condition or same support condition in two directions. So with that, we have to select the smallest area moment of inertia. So with that, we can go ahead to determine the critical load here. Pi square E for steel, as I showed you, 836, it will be 29,000 KSI. And then for the I, and here I have to be IY, so it is 21.8 and divide by K. What is K in here? So as you can see, for the K, we go back to our node with both ends are pins. The effective plant factor is K equal to 1, which is the scenario B that we have it here, K1. So we can plug in that equation is 1. And then what is L? L is the length, actual length. And in here is 6 feet. So for 6 feet, it equal to 6 times 12, so 72 inches. So we can plug that one in time 72 inches in that equation and power 2. And from that, we will determine the critical load, critical. It equal to 1202 kips. 1202 kips. And the question is, what is the factor of safety with respect to buckling? So we can determine the factor of safety with respect to buckling. It equal to, as you already know, the actual. You see the actual, so it will be P. In that case, as you can see, P failure divide by P actual, and the P actual here, it actually that is P actual. The load really apply on the structure, it's 100 kips. It's 100 kips. So from that, we have it 100 kips. And the P failure in this case, the P critical for the buckling, so it will be 1202 kips. So from that, we have the factor of safety is 12.02. 12.02. That's very big number there. So the factor of safety with regard to buckling, that is 1202. Now, if we have to consider the yielding or crossing in that scenario, just like the example we have. So if consider yielding, so or crossing, so we want to have the sigma actual. If you recall the sigma actual of this, determine the load stress on that member. Sigma actual is equal to P actual divided by P actual, the actual load applied on that member, divided by the areas of that member. So it will be equal to 100 kips divided by A, so 3.2 times 8. This is the rectangular cross section. So from that, it equal to 3.80 KSI. So that is the actual normal stress, compressive stress applied on that member. So you can say that it KC for compressions. So the factor of safety, here, remember, this is the stress. So we have to compare with the urine stress for the failure due to urine or crossing. So from that we can have factor of safety due to urine, and in that case it equal to the sigma failure divided by sigma actual, and sigma failure in this case urine, so you can see that is sigma y, and sigma 0 is 36 KSI for the A36 steel. So from that we can plug in 36 divided by 3.80, and from that we will get it 9.21. That is the actual factor of safety due to urine. So from here, as you can see, if the factor of safety for the urine is less than the factor of safety due to buckling, what does that mean? If we keep increasing the load from 100 keep increasing, the first failure it will be urine, not buckling, where the factor of safety of urine is less. So what does that mean? It fail, then the urine first. So as you can see that one, because the factor of safety of U is less than factor of safety, as you can see, factor of safety of urine is less than the factor of safety due to buckling. What does that mean? It will yield first, and when the member is yield first or cross first, then if you recall the demonstration and the example in the lecture note, it will, we call that a short column. That will be a short column. Okay, so with that we finished part A, and for the next video I will use part B. And again, this part A and part B have different in the term of determine the I area moment of inertia for cross section given in the critical load of the Euler equation, Euler buckling equation, because the support end conditions for X and Y axis are not the same in part B. So with that, this problem worksheet for part A and B, very important, include many concepts that you need to practice to understand, and before you get into the next 3 worksheets.